Hello everyone. Today we'll see about rectifier and types of rectifier, which is half wave rectifier and full wave rectifier. As we have discussed in the previous sessions, a rectifier is an electrical device that converts alternating current into a direct current by using one or more PN junction diodes. So how this is getting converted from AC to DC is that when the diode is working in forward bias, I'll be getting an output for the given corresponding input signal, and when it is working in the reverse bias, I'll not be getting any output. So the signal will be present in the positive half cycle. So we normalize that signal to be converted by given AC signal is converted into DC signal. So first we'll have a short discussion about this half wave rectifier. A half wave rectifier uses a single diode with a transformer setup. So for the positive half cycle of the input signal, the diode is actually forward biased. So the signal that I'm giving as input will be reflected back in the output side. So when I give a negative signal as the input, the diode is going into reverse bias. So the diode will not conduct and the circuit becomes open. So I say that for the positive half cycle, I'll be having an output, and for the negative cycle, I'll not be having any output. So this is a circuit to tell about the operation of half wave rectifier. So when I'm giving a positive half cycle as input, the polarity is considered to be positive. So the positive and the positive terminal of my diode makes it to be forward biased. So the diode is acting as a closed switch. So the circuit becomes closed and the input signal flows from my terminal to the load resistor. So I am getting the output. But when I go into this negative signal of my negative portion of my input signal, the polarity is negative. So the negative polarity and the positive terminal of my diode will make my diode to move to reverse bias. So it will act as an open switch. So the diode becomes open and no current flows from the positive terminal to the input terminal to the load resistor. So having a comparison between the input signal and the output waveform that I have received, I will have my output only whenever my input is there in the positive half cycle. So the negative portion of my input signal is being completely waste, which is a disadvantage. So to overcome this disadvantage, we are moving to this next type of rectifier, which is a full wave rectifier. In a full wave rectifier, there is one component which is being added additionally to my half wave rectifier. Here I am using two diodes with a center taped transformer. So how these two diodes work is that for one portion of my input signal, my diode D1 will be forward bias and diode D2 will be reverse bias. For the other portion, my diode D1 will be negative bias, which is reverse bias, and the diode D2 will be forward bias. So by considering the output of diode D1 and D2, I will be combining both the input. I'll be getting my output waveform, which will be DC in nature. So this in a center taped transformer, this center tape, the voltage of the center taped is considered to be the reference voltage. So now seeing how this full wave rectifier works in the positive and the negative half cycle is that for the positive half cycle, if you see, my diode D1 is forward bias and diode D2 is reverse bias. So I am moving from the signal flow will be from the transformer terminals to diode D1 and the load resistor. So my output will appear as such. So when coming to the negative half cycle of my input signal, the flow will be my diode D1 will be reverse bias and D2 will be positive bias. So the signal flows from terminals of my transformer to the diode D2 and the load resistor. So I am giving my signal in the negative portion, but I am getting my output in the positive phase. That is because of the usage of this center taped transformer. The nature of this center taped transformer is that it shifts or provides a phase shift of 90 degree for alternative cycles of my input signal. That is the reason For the positive half cycle, I get the positive signal as it is, and for the negative portion of the cycle, I am getting a phase shift of 90 degrees. So from negative cycle, it is moving to the positive half cycle. So this is the full wave rectifier waveform. I am getting the output from diode D1, D2, and by combining, I am getting a single signal as the output. So this bridge rectifier is another type of full wave rectifier, but the reason why we are moving from a full wave rectifier to a bridge type full wave rectifier. So when you see in this full wave rectifier, a normal full wave rectifier, we are actually in need of a transformer. Considering a transformer with two diodes is a bit complex. So in this bridge wave rectifier, this transformer is actually removed by using a simple input signal. So by replacing that transformer, we are using 4 diodes instead of 2 diodes. So the circuit becomes much more easier when compared to the full wave rectifier with the use of this transformer. So how this circuit works is that, as we have seen in a full wave rectifier with transformer, for one portion of the signal, diode D1 will conduct and D2 will not conduct, and for the other portion, my diode D1 will not conduct and D2 will not conduct. So similarly, in this bridge wave rectifier, we are using 4 diodes, where one pair of diode will be conducting for one cycle of my input signal and the other pair does not conduct. So when it moves to the other phase of my input signal, the alternate pair will be conducting and the remaining pair will not be conducting. So we will see how this is actually working. So as in our full wave rectifier with this transformer is actually optional when we are using this, when we are moving to this bridge rectifier. So since it is optional, this circuit diagram gives my input signal also in the diagram as well as the transformer also. So when I am using my bridge wave rectifier, what happens, as I told you, one pair of input, one pair of diode will be working for one portion of my signal. So when I have my input signal which is positive in nature, I will have my diodes D1 and D2 which is forward bias, that is my diode D1 and D2 will be forward bias, and diode D3 and D4 will go to the negative, will go to the reverse bias. So whenever I have my positive half cycle as input signal, D1, D2 will conduct, D3, D4 will not conduct. So the flow of my signal will be from the input signal, it goes to the winding, and from the winding to the diode D1, then across the load resistor, then to D2, then in the same way it will go as cycle. So D1, this load resistor can be connected separately also. So I will be measuring my output voltage across the terminals of my resistor. So the flow will be from D1 D2 resistor. D1 D2 resistor will be the flow of my signal when I am giving my positive cycle as input. So now coming to this negative half cycle of my bridge rectifier, it will have I am giving my negative portion of my input signal. When I am giving my negative portion of my input signal, it will be a reversal of the positive half cycle. My diode D1 and D2 will go to the reverse bias and D3, D4 will start conducting, which will be in forward bias. So the flow of my input signal will be from the terminals to diode D3 and across the resistor D4 across the resistor. So this is how my cycle will move on. So whichever diode is conducting, my signal will go through only that diode and the signal will not pass on into the diodes where it is not conducting. So I am getting my output signal. So this is a output waveform of my bridge rectifier, where I have an input signal and the output of diodes D1 and D2 which is there in the positive half cycle, and diode D3 and D4 which is there in the negative half cycle. So here I am combining the outputs of my diode D1 D1, D2, D3, D4, and I am having the complete output where the entire signal that I've given as input signal is converted into its equivalent DC. So in this session we have seen about what a rectifier is, the types of rectifier, full wave rectifier and a half wave rectifier. The full wave rectifier itself is of two types, where a full wave rectifier by the usage of transformer and a full wave bridge rectifier where my transformer is replaced by an input supply, but the working of full wave rectifier with and without transformer is the same, where the given input signal is being completely utilized. Thank you.